In this video, we're going to be learning about dividing signed numbers. We're going to relate division to the multiplication of signed numbers that we did in a previous video. So what we're going to do for these first few examples, we're going to take three different numbers, and what we're going to do, we're going to write two multiplication problems based off of the rules that we learned for multiplication. And then, since division is the opposite or the inverse of multiplication, we're going to write two true division facts based off of our fact family. In our first example, the fact family that we're going to use is 3, 5, and 15. I can make two true multiplication sentences from these three numbers, namely that 3 times 5 is 15, or I could use the commutative property here and say that 5 times 3 is 15. Both of those are true multiplication facts. All right, and again, since division is the inverse of multiplication, what I'm going to do, I'm going to take the product, which was 15, and I'm going to divide it by one of the two numbers, all right? So if I wanted to divide by 3 first, well, because 3 times 5 is 15, then if I take the 15 and divide it by the 3, then the result has to be equal to 5. All right, similarly, if I started with the 15, the product, and I divided it by the other number first, 5, then what I'm going to have to get as a result is the other member of the fact family, which is 3. So since 3 times 5 is 15 and 5 times 3 is 15, it's true that 15 divided by 3 is 5, and 15 divided by 5 is equal to 3. All right, both of these division problems confirm the first rule of division that you already knew from elementary school. If you take a positive number and you divide it by another positive number, then your quotient, which is the answer to a division problem, is going to be positive. All right, positive divided by positive is positive. Positive divided by positive is positive. Again, that's a rule that you've learned or that you learned a long time ago and have known since elementary school. What we're going to be doing later on in this video is incorporating negatives into our division problems. The next fact family that we're going to look at is the 6, -3, -18 fact family. And this is a fact family because, again, I can take these numbers and make two true multiplication facts from them. All right, so if I take 6 and I multiply it by the -3, all right, well, I knew 6 times 3 was 18. And I also learned that a positive multiplied by a negative is a negative number. So 6 times -3 is -18, which is why those are the three numbers in this fact family. All right, similarly, I could use the distributive property and start with the -3 and multiply it by the 6. All right, and I should say that's the commutative property. And -3 times 6 is also going to be -18. Based off of these multiplication facts, let's come up with two true division facts. All right, if I start with the product, which was -18, and I divide by one of the members of the fact family, which I'll use 6, then I have to get the other member of the fact family, which is -3. -18 divided by 6 is equal to -3. And this problem here shows a new division rule. If I start with a negative number, and I divide it by a positive number, then my quotient is going to have to be a negative number. A negative divided by a positive is a negative. And that is your second rule for division. All right. Now there's another true multiple or division fact that we're able to make from this fact family. Again, if I start with the product, which was -18, and I divide it by the other member of the fact family first, which -3 this time, since I divided by 6 first over here, then the answer, the quotient, has to be the third member of the fact family, which in this case is 6. So this division problem shows yet a third rule of division. If I start with a negative number and I divide that negative number by another negative number, then the quotient this time has to be a positive number. A negative divided by a negative will be equal to a positive. A third fact family that we can look at is the -8, -2, +16 fact family. Once again, this is a fact family because I can make two true multiplication facts out of these. If I take -8 and I multiply it by negative 2, well, the product here is going to have to be equal to 16. All right, 8 times 2 is 16, and we learned that a negative number multiplied by a negative number is a positive number. So negative 8 times negative 2 is equal to 16. Using the commutative property, I can also say that negative 2 times negative 8 is 16. Now from these multiplication facts, let's make two true division facts. If I start with the product of 16 and divide by negative 8, then I have to get the third member of the fact family, which is negative 2. Or if I start with 16 and I divide it by the negative 2, then I have to get negative 8, which is the third member of the fact family. Both of these division problems show the exact same fourth rule for division. If you start with a positive number and divide by a negative number, then your quotient needs to be negative as well. Rule number 4, a positive divided by a negative is going to be equal to a negative number. All right. Now, these 4 rules sound very familiar to the rules for multiplication, and they should. Okay, the rules for multiplication and division follow a similar pattern. Part A, if the two numbers involved in a multiplication problem or a division problem have the same sign, so they're either both positive or both negative, then your result is going to be positive. Okay, two of the same sign, when you multiply or divide, your result will be positive. But if the two numbers involved in your multiplication or division problem have different signs, so you have one positive number and one negative number, then your result is going to be negative. Okay, multiplying or dividing two numbers with different signs will always give you a result that is negative. Another area of division that we need to investigate is when the number 0 is involved. You could be dividing the number 0, or you could be dividing by the number 0. All right, these sound the same, but they're actually meaning two different things. Okay, so if you're dividing the number 0 by a number, for example, 0 divided by 4, all right, well, you're starting with nothing, and you're taking nothing and dividing it into 4 equal groups. Well, if you take nothing and divide it into 4 equal groups, then your result in each group, you're going to have nothing. All right, so if you're dividing the number 0 by some number, then the quotient will always be 0. All right, 0 divided by a number is going to be 0. However, if you're dividing a number by 0, all right, so this is where it's a little bit different. Dividing by 0. So maybe I'm doing 4 divided by 0. All right, well, I can't take 4 things and divide them into no equal groups. All right, I could divide them into one group, I could divide them into 2 groups. I can't take 4 things and divide them into no groups, though. This isn't possible. All right, and in fact, if we were using a calculator in this example, your calculator would give you an error because this can't be done. So if you're dividing a number by 0, the quotient, we say, will always be undefined, which means mathematically it's impossible. Okay, so don't confuse these two. Again, they sound very similar, but they mean two different things. If you're dividing 0 by a number, then the answer is always 0. But if you're dividing some number by 0, that's impossible, and we call that undefined. Since dividing with negatives is something new for us, we need to discuss the placement of the negative symbol in your division problem. All right, this question asks, are the following quotients equivalent? All right, notice in each case we can see an 18 and a 4, and then we have a negative symbol in each example. Now in this first one, the negative symbol is out front. In the second one, the negative symbol is in the numerator. And in the third one, the negative symbol is in the denominator. What we're going to do is start with this middle example, negative 18 divided by 4. And in this example, well, I already know the sign rules for division. I know that a negative number divided by a positive number is equal to a negative number. So this is going to be some negative number. And now I just have to figure out how many times 4 goes into 18. All right, well, 4 goes into 18 4 times, and 4 times 4 is 16, which means that there's 2/4 left over, but 2/4 is the same as a half. So this negative 18 divided by 4 is equal to negative 4 1/2. All right, looking at this third example, 18 divided by negative 4. Well, again, I know the division rules say that a positive divided by a negative must be a negative number. And again, 4 goes into 18 4 times with 2/4 or 1/2 left over. So these two examples are definitely equivalent to each other. All right, negative 4 1/2 equals negative 4 1/2. So yes, those are equal. Okay, but what about this one where the negative symbol is out front? Okay, well, when you have this negative symbol out front, this negative symbol right here is really the number -1. Okay, so I can rewrite this. This is really the number -1, and it's multiplying whatever the answer to 18 divided by 4 is. Well, we just said a couple of times over here that 4 goes into 18 4 times with 2/4 or 1/2 left over. So this is -1 times 4 1/2. And I know that a negative times a positive is a negative, so this is also -4 1/2. So yes, these three fractions, these are all equivalent to each other. So when you have a problem where there's one negative in the example, all right, you can place that negative symbol either out in front of the fraction, you can place it in the numerator of the fraction, or you can place it in the denominator. All three of these show the exact same thing. They're all equal to -4 1/2. All right, now, preferably, I like to put the negative symbol either out in front or in the numerator. All right, I'm probably going to write it both of these ways here. Very rarely will I actually put the negative symbol like that in the denominator. Okay, but just know that if you see something like this, all three of these are equivalent to each other. Now that we're familiar with the sign rules for division, we're going to take our knowledge of those sign rules and apply it to something that you learned about in elementary school, dividing fractions. All right, when you're dividing fractions, remember there are two ways that you can actually divide these fractions. You can get common denominators to do division, but you don't have to, all right? But you can do it that way, or you can do something which is called multiplying by the reciprocal. I'm going to show you both methods. You'll pick the one that you like the best. If we do the common denominator method, all right, here we have 4/9 divided by 2/15. I'm going to first get common denominators. And with ninths and 15ths, their common denominator is going to be 45. So I'm going to rewrite this division problem so that the denominator in each fraction is 45. 9 times 5 is 45, so 4 times 5 is going to be 20. And then 15 times 3 is 45, so 2 times 3 is 6. So now our problem says 20 45ths divided by 6 45ths. And when you have common denominators, all you need to do is divide straight across, just like you kind of would do when you're multiplying, okay? Now, the denominator is easy. If you do 45 divided by 45, well, any number divided by itself is 1. But your numerator is going to be whatever the answer is to 20 divided by 6. Okay, so you're going to take 20 divided by 6, whatever that happens to be, and then you're going to divide it by 1. All right, but dividing any number by 1 is going to leave it unchanged. So I really don't even need to think about the denominator anymore. I just have to figure out what 20 divided by 6 is. And remember that a division problem you can rewrite as a fraction. So 20 divided by 6 is the same as the fraction 20/6. And now all I really need to do is take that fraction 20/6 and simplify it. 20 and 6 are both even, so they're both divisible by 2. So that would make my fraction 10/3 when I simplify it. So 10/3 could be the answer to this question. You could also change it into a mixed number. 3 goes into 10 3 times with 1/3 left over. All right, so the quotient to this problem, 4/9 divided by 2/15, is either 10/3 or 3 1/3. All right, so that's using your common denominator method. Now, another method would be by multiplying by your reciprocal. If I have 4/9 divided by 2/15, I can actually take this multiplication problem and change it, or this division problem rather, and change it into a multiplication problem. All right, and the way that I'm going to do that, I'm going to leave 4/9 alone, and then I'm going to multiply by 2/15 reciprocal. Well, remember that reciprocals just replace where the numerator and denominator are located. The reciprocal of 2/15 is 15 halves. All right, dividing by 2/15 is the same as multiplying by 15 halves. We just multiplied by the reciprocal. And now I can use my rules for multiplying fractions. Before I multiply, I'm going to see if I can simplify. And I definitely see I can simplify with the 4 and the 2. Their common factor is 2. 2 goes into itself once. 2 goes into 4 twice. All right, now I'm going to look for other simplifying. And I know that 9 and 15 have a common factor of 3. 3 goes into 9 3 times, and 3 goes into 15 5 times. All right, and now I don't think I see any more simplifying. 2 can't simplify with 3 or 1. 5 can't simplify with 3 or 1. So now all I'm going to do is multiply. In the numerators, 2 times 5 is 10. And in the denominators, 3 times 1 is 3. And that again gives me the same answer that I had before, which was 10/3, which is also again equivalent to 3 1/3. So both of these methods give you the exact same answer. It's up to you as to which one you would like to use. Would you rather get common denominators, or would you multiply by the reciprocal? All right, this method, multiplying by the reciprocal, tends to be a favorite among most students. Okay, so again, they gave us the same result. Now let's see what we would do if we were dividing with mixed numbers. All right, and very similarly, when we multiplied with mixed numbers, the first thing that you're actually going to do here is turn all of your mixed numbers into fractions first. Once you turn your mixed numbers into fractions, well, then your problem is going to look like what we just did right up here. All right, so let's take 2 1/3 and divide it by 3 1/2. Let's make them fractions. 2 1/3, well, 3 times 2 is 6 plus 1 is 7. That's 7/3. And I'm going to divide that by 3 1/2. 2 times 3 is 6 plus 1 is 7 halves. So this is 7/3 divided by 7 halves. Now that you're dividing just fractions, decide, do you want common denominators, or do you want to multiply by the reciprocal? I'm going to multiply by the reciprocal. That's my preferred method, meaning that 7/3 is unchanged. But instead of dividing by 7 halves, I'm going to multiply by 7 halves reciprocal, which is 2/7. All right, so now I have 7/3 times 2/7. I'm going to see if I can simplify. And I definitely can. I have a 7 in the numerator, a 7 in the denominator, which both become 1s. And now there's no more simplifying left to do. So now when I go ahead and I multiply, 1 times 2 is 2. 3 times 1 is 3. We get the fraction 2/3. So 2 1/3 divided by 3 1/2 is equivalent to 2/3. Let's go ahead and practice dividing signed fractions. The process is going to be exactly the same as dividing regular fractions. You're just going to try to see what the sign of the answer is going to be based off of your division rules. And looking at the first example, -5/6 divided by -2/9, well, I know that a negative divided by a negative is going to be a positive. So my answer in this example will be positive something. All right, let's see if we can figure out what that is. I'm going to use the multiply by the reciprocal method for these examples. So that means that in this example, -5/6 is unchanged, and we're going to multiply by -2/9 reciprocal, which is -9 halves. -5/6 times -9 halves. Now I'm going to check to see if I can simplify before I multiply. I have a numerator of 9 and a denominator of 6 that have a common factor of 3. 3 goes into 6 twice. 3 goes into 9 3 times. I don't see any other simplifying that can be done. Neither the 5 nor the 3 can simplify with these 2's. So now I'm going to go ahead and multiply. In the numerators, 5 times 3 is 15. In the denominators, 2 times 2 is 4. And again, the sign here had to be positive because a negative times a negative is a positive. So we get the fraction 15/4, which is in simplest form. But now we can take that and we can make it a mixed number. 4 goes into 15 3 times. with 3/4 left over. So either of these examples or answers would be acceptable, 15/4 or 3 3/4. Looking at our example B, all right, well, this is something that's called a complex fraction. All right, a complex fraction is when you have a fraction within a fraction. So here's our fraction bar, and notice that the numerator is a fraction, but so is the denominator. All right, when something is looking like this, well, it's really not that intimidating as long as you remember that a fraction represents a division problem. So all this is saying is take negative 2/3 and divide it by 24/27. That's what that complex fraction means. Okay, so now it looks kind of like what we did over here. I'm going to use my multiply by the reciprocal form to figure out what the answer is going to be. So I'm going to keep negative 2/3 unchanged. I'm going to multiply by 24/27 reciprocal, which is 27/24. And now I'm going to see if I can simplify before I multiply. Well, 3 and 27, they happen to have a common factor of 3. 3 goes into itself once and into 27 9 times. 2 and 24 also have a common factor of 2. 2 goes into itself once and into 24 12 times. I can still simplify because I have a numerator of 9 and a denominator of 12, which have a common factor of 3 again. 3 goes into 9 3 times and into 12 4 times. And now I've simplified as far as I can go. So now I'm going to multiply my numerators. 1 times 3 is 3. Denominators, 1 times 4 is 4. And for the sign, it was a negative times a positive, or a negative divided by a positive, which is going to be negative. And so the answer to this complex fraction, this division problem, is negative 3/4. Finally, in example C, we've got some mixed numbers. Again, working with mixed numbers, the first thing we're going to do is change them into fractions. 3.5. 2 times 3 is 6 plus 1 is 7, so that's 7/2, divided by negative 1 2/5. Well, that's going to be negative 5 times 1 is 5 plus 2 is 7, so that's negative 7/5. Let's now multiply by the reciprocal. 7/2 is unchanged. And we'll multiply by negative 7/5 reciprocal, which is negative 5/7. And now we'll see if we can simplify. We definitely can. 7 in the numerator, 7 in the denominator. 7 goes into itself once. No other simplifying can be done here. 5 can't simplify with 2, and so we go ahead and multiply. 1 times 5 is 5 in the numerator. 2 times 1 is 2 in the denominator. Positive times negative. Positive divided by negative, the answer here is going to be negative. So I could say negative 5/2 is the quotient. Or again, I can change that into a mixed number, negative 2 and 1/2. 2 times 2 is 4, so there's still 1/2 left over. So again, either of these two answers would be acceptable. You could write negative 5/2, or you could write negative 2 and 1/2. So again, the rules that you learned about in elementary school for dividing fractions still apply. Now you're just going to apply your sign rules to your answers.